Okay, so in this lesson we're going to talk about trigonometry. Trigonometry is a subsection or subcategory of geometry, and it's so popular actually that it has its own specific kind of study, and you can take the class trigonometry in college, or we even have a trigonometry class attached with pre-calc here at Meade High School. So let's jump in. Trigonometry, trigonometry. I think there's a song about that. That's kind of why I put it up there. But the idea, though, is that there are three trig ratios. Okay, the three trig ratios are sine, cosine, and tangent. Okay. Now, if you ever like explored a calculator, or at least the scientific calculators, you'll see that they all have this SIN, COS, and TAN button, okay? And that's basically the three trig ratios. And we'll work with these later, but the idea that we can abbreviate sine, cosine, and tangent, if you've seen them on a calculator, you might wonder what they are. But I'm going to, above here, just write the abbreviation for sine, cosine, and tangent. So sine is SIN, cosine is COS, and then tangent is TAN. Okay. Now, in this, trigonometry is basically just there's trig, three ratios, so three sides. It's also talking about a triangle, specifically a right triangle. Now, because a right triangle has three sides, we end up labeling these three sides specific names. So always in a right triangle, you have a hypotenuse. So the three sides that we have are one going to be a hypotenuse. Then we have also what we call the opposite side, and that's always opposite of some angle, and then the adjacent side, and that's next to the angle. Okay. So down here, just these trig ratios, sine, cosine, and tangent, are actually just fractions. It's a length, or whatever you would want to call it, a length or a side in the triangle divided by another length or side in the triangle. Now, to put this like as a trig ratio, we're going to play the sine, and again I'm going to abbreviate sine as SIN. Now, we always take the sine of some angle. So we have a right triangle, there's going to be the sine of the angle is the opposite side of that angle divided by the hypotenuse of the triangle. The cosine is next. The cosine, again, of some angle in the triangle is going to be the adjacent side to that angle, all divided by the hypotenuse of that triangle. And last, the tangent of some angle is the opposite side of that angle divided by the adjacent side of that angle. Okay? Now, there's a really popular acronym out there to remember these ratios. Unless you just want to memorize these fractions, there's an acronym to help you remember it, and it's SOHCAHTOA. So I'm going to spell it out, and I'm purposely capitalizing this S. So SOH, and then SOHCAH, CAH, purposely capitalizing the C, and then TOA, TOA, purposely capitalizing the T. Okay. Now, SOHCAHTOA, what I've always been told, is just a famous Aztec warrior. So if you want to imagine him as an Aztec warrior, here's his lips and his eyes and whatever, and maybe he has a little Adam's apple or something, and warriors might have a mohawk. So here's his mohawk, and there's all the hair that they shaved off with his ear. Anyways, whatever, I draw that picture. That's SOHCAHTOA. He's a famous warrior. This is how you spell his name, but specifically this acronym stands for sine is equal to the opposite over the hypotenuse, so O over H. Cosine is equal to the adjacent over the hypotenuse, AH. And then tangent is equal to the opposite over the adjacent, OA. So SOHCAHTOA. Now, if you're bad at spelling and you can't remember this all the time, here's an acronym that I have always used, okay? And it's some old horse caught another horse taking oats away. And again, I've bolded the S, C, and the T, but again, this is just it's a mnemonic device to help you remember all of these ratios. So the S represents the sine, and that is a fraction that is equal to the opposite divided by the hypotenuse. The cosine, C for caught another horse, is equal to the adjacent side divided by its hypotenuse. And then the T for taking oats away is the tangent, which is equal to the opposite divided by the adjacent. Okay. So we have our three ratios. You can remember SOHCAHTOA, or you can remember some old horse caught another horse taking oats away. I usually use this because spelling may not be the best. You can spell SOHCAHTOA maybe multiple different ways, but this is the idea. Some old horse caught another horse taking oats away. And we're going to jump down to these triangles down here. Okay, now trigonometric ratios, sine, cosine, and tangent, only work with specifically right triangles. You can't take an equilateral triangle or something without a 90-degree angle and use these same ratios. It has to have right triangles. And we always are working relative to some angle. Okay, so specifically in this triangle, we're asking the sine of the angle y. So we're really talking about this angle y up here. Okay. And I'm going to label the side, opposite, hypotenuse, and adjacent according to this angle and this triangle. Well, we know that the 90-degree angle is always opposite the longest side, which we call the hypotenuse. So I'm going to label that HYP for hypotenuse. So 10 is the hypotenuse of this triangle. Now the opposite side of this triangle is just opposite, is on the other side of the triangle that doesn't touch y. The side length 6 is opposite the angle y. And then the last side length that we call is adjacent, and that is the side that is next to this angle, but not the hypotenuse. So the hypotenuse and the adjacent side will make the angle y. So we have hypotenuse, adjacent, opposite. Now if we go to the sine ratio, okay, sine is some old horse, so it's opposite over hypotenuse. So the opposite over the hypotenuse. Now in this triangle, those have side lengths. The opposite side is 6, the hypotenuse is 10, so it's 6 over 10. Now we can reduce this. Really, right now, this is more important. But if we reduce this, the 6/10 can be divided by 2, both top and bottom, and become 3/5. Okay? So basically, the sine ratio is the same. It's 6 over 10 or 3 over 5. Now I'm going to jump to cosine. Cosine is caught another horse, so the adjacent over the hypotenuse, so A over H. So the adjacent of y is 8, the hypotenuse is 10, so this is equal to 8/10. And again, this fraction can reduce down to 4/5. So these are equivalent to the sine, or the cosine of y. The last one, tangent. Tangent, taking oats away. Oats away is the opposite over the adjacent, so opposite over adjacent. And in this one, the opposite is 6, the adjacent is 8. So 6 over 8 is our fraction. And that can reduce, again, to 3/4. So even though 6 over 8 has the side length, 3/4 is the reduced trig ratio for that angle y. So that's all according to y. We're going to go and switch, and we're going to change the angle. So where this was tangent of y, now it's the z angle. So if the angle changes, we're now going to have to change the sides of the opposite and the adjacent. So now we're talking about z, so we're talking about this angle z right there. The hypotenuse will never change. That's always along a side, always across from the 90-degree angle. But now, according to the z, the opposite side is 8. So we change the angle. The opposite side goes from adjacent to opposite once the angle changes, and that leaves 6 to be the adjacent side. So filling out these trig ratios, the sine of z, sine is some old horse, so opposite over hypotenuse, and the opposite side is 8, the hypotenuse is 10, 8 over 10, and that reduces to 4/5. Notice that they're the same. Cosine, caught another horse, caught adjacent over hypotenuse, equals 6 over 10, so 6/10, and that again reduces to 3/5. These are the same. And then the last one, tangent of z, taking oats away, opposite over adjacent. The opposite is 8, the adjacent is 6. 8 over 6, which is 4/3. Okay. But really, these give the side lengths here. So now that you're finished with the front side, we're going to flip to the back side, and we're going to do the trig ratios for three more trig ratios for the triangle back here on the back. Now, I'd like you guys to try it, so at this point you can pause the video, and then the video will continue after you unpause it, and we can see if you get them correct or not. But I'm going to continue with this. You can pause right now, and then do these on your own and check later. Sine of A. A is this angle. So the hypotenuse of A is 40. It's always the hypotenuse. The opposite is 24, and the adjacent to A is 32. So sine, some old horse, opposite over hypotenuse, 24 over 40. Now, if I reduce that, both of those are divisible by 4. So it'd be, or they're both divisible by 8 as well, 3 over 5, so 3/5. Tangent of A, taking oats away, opposite over adjacent. The opposite side is 24, the adjacent is 32, so 24 over 32. Again, divisible by 8, so that fraction will become 3/4. The last one's a little different. Now I'm going to change the color of my pen because C now is over here. So we don't really worry about the opposite and adjacent anymore because now opposite of C is 32 and the adjacent to C is the 24. So cosine caught another horse adjacent over hypotenuse is going to be the 24 over 40, which is equal to, just like we had over here, 3/5. But again, these are the trig ratios that give the side length specifically, and these are the reduced trig ratios. Now, I've had the question, well, we never use B, ever. Well, that's because B is at the right angle. So you will never take the cosine, sine, or tangent of the 90-degree angle, okay? In this case, it's B, okay? And that's because the opposite side of B is also the hypotenuse of the triangle, and then you would have two adjacent sides. So that would screw up the trig ratios. So the opposite side of B is also the hypotenuse, and that screws stuff up. So we will always work the non-right angles, C and A in this example. Okay. So now we're going to draw a triangle. Now we know that because we're taking sine, this has to be a right triangle. Okay. All the sine, cosine, tangent, trig ratios are working with right triangles. Now the sine specifically of A is equal to this fraction 12 over 23, which means sine is opposite over hypotenuse, some old horse. So the opposite side over the hypotenuse makes the opposite 12 and the hypotenuse 23. So I'm going to draw a right triangle over here. And I'm going to label this side A right here because that's the angle that we're talking about. That means that the opposite side of A needs to be 12. And then the hypotenuse of this triangle needs to be 23, just like the fraction says. Now, this isn't the only way that this triangle can be drawn. You could also have a triangle drawn over here where the angle A is up top. So the opposite of A would be 12 down here, but the hypotenuse would never change, 23. So either one of these could be a correct drawing for the triangle that has a sine ratio of 12 to 23. Next example. We're going to jump to the tangent. Tangent again, taking oats away. So this is equal to the opposite over the adjacent. So that means in this right triangle, 3 is the opposite, 4 is the adjacent. So I'm going to draw a right triangle where, and just for this case, I'm just going to leave B. I'm not going to draw two triangles. The opposite of B is going to be 3. And then the adjacent to B is going to be 4. And we don't know the hypotenuse, so we leave it blank. So that's just a drawing for the tangent of an angle B that has 3/4 as its ratio. Now in the same triangle, so right here, this triangle with angle B, what is the cosine of B? So if we take the cosine of B, cosine is caught another horse, so the adjacent over hypotenuse. The side that we need, what additional side to fit this? Well, we have the adjacent, we have the opposite, but we need the hypotenuse. But, I mean, you can use the Pythagorean theorem, 3 squared plus 4 squared. You might already figure out that the hypotenuse is 5 because we know this is a 3, 4, 5 right triangle. So specifically, the cosine in this of B is going to be the adjacent side 4 over the hypotenuse 5.